Hi guys, today we are going to shift our discussion from engineering mechanics to soil mechanics. This is a prerequisite course of foundation engineering for civil engineering students. We are going to discuss AASHTO soil classification system. This soil classification system involves particle size composition and plasticity characteristics of the soil sample. We are going to use the AASHTO classification chart in order for us to determine the classification of the soil and its rating as subgrade materials. So we are going to use a classification chart. The instructor should provide you this sheet of paper showing different columns of general classification and group classification of given soil sample. So we are going to discuss first the components of the chart. On the first column, we have the general classification, and this general classification is granular material and silt clay material. On the second row is the group classification, in which this granular material is subdivided into 2 or 3. We have A-1, A-2, and A-3. Okay? For silt clay materials, this is classified as A-4, A-5, A-6, and A-7. So all in all, we have 7 group classifications, 3 for granular and 4 for silt clay. The next is we must have data from SIP analysis, the percent passing number 10, number 40, and number 200. And then we should have a data from the Atterberg limits test. We have the liquid limit in percent, the plasticity index. And from that, we can determine the group index of each sample. Group index indicates whether the group subgroup classification is good or poor. Take note that the higher the group index, the poorer the material included in the soil sample. And then below the materials, we have the rating. AASHTO gives rating for each group classification. Okay, so we are going to discuss the A-1 group classification under the granular. The question is, how are you going to determine if the soil specimen is granular or silt clay? So, take a look at the number 200, the percent passing number 200. For granular, it should be 35% or less. Okay, this is number 200. So first thing is to check the percent passing number 200. If it is 35% or less, therefore it is a granular material. Okay? So, next is we are going to know if the soil sample is under A-1, A-2, or A-3. Okay? So let's say if we have the given data as for number 10 we have 88%, number 40 let's have 75%, and then number 200 let's say 34%. We have the liquid limit as 39 and plasticity index of 12%. Okay. So we have this data, SIP analysis data, and then the Atterberg limit test data. We are going to determine if it is granular or citrate. Okay, the first thing is to check number 200. The percent passing number 200 from our data is 34%. The requirement for granular is 35% or less. That means we are going to focus our attention on this column, which is the granular, because granular requires the number 200% passing as 35% or less. Since we have 34% here, then we focus our attention on this granular column. Okay, starting from the left, from left to right, we are going to use the elimination process so that we will arrive to the correct classification of the soil sample. Okay, number 10. For A-1, this is divided further into A-1-A and A-1-B. Okay? Take note. For A-1 group classification, this is divided again into two, A-1-A and A-1-B. Okay? From the table, for number 10, we have 0 to 50% under A-1-A. Okay? Our data is 88% passing number 10. A-1-A is only up to 50. So A-1-A is not our group classification. Okay? Let's proceed to A-1-B. From the table, we have a requirement of number 40 of 0 to 50. Okay? From our data, percent passing is 75%. AASHTO requires only from 0 to 50. Therefore, A-1-B is not our group classification. Going further to the right, we proceed to A-2 and A-3. So A-1-A and A-1-B is eliminated from our classification. We proceed to the next classification. We have A-3 first. A-3. A-3 requires number 40 to 51, from 51 to 100. Again, AASHTO requires number 30% passing from 51 to 100%. From our data, we have 75%. So this requirement is satisfied. Okay, going down further at number 200, AASHTO requires us to have 0 to 10%. Again, based from our data, we have 34% passing number 200. AASHTO has only up to 10%. Therefore, this is not our group classification. So, we now proceed to A-2. Again, A-1 is eliminated. A-3 is also eliminated. Let's proceed to A-2. Under A-2, we have further classification. Okay. A-2 we have 4. A-2-4. A-2-5. A-2-6. And A-2-7. Okay. Here. Starting from A-2-4 going to A-7. Remember, our procedure is we start always from the left using the classification chart. For the A-2-4, it requires 0 to 35 for the number 200. Okay, our data is 34%. A-2-4 is from 0 to 35. Therefore, this requirement is satisfied. Okay? Going down farther, let's check the liquid limit. The AASHTO requires us to have a liquid limit of 0 to 40. Our data is 39% liquid limit. Therefore, 0 to 40 is satisfied under A-2-4. Okay? Going down farther, let's check the plasticity index of our soil sample. We have 12% here. The AASHTO provides us 0 to 10. Okay? Again, from our data, the plasticity index is 12%. The AASHTO requires us to have 0 to 10. Therefore, this is not satisfied. A-2-4 is eliminated. Okay? Next, let's try A-2-5. Under A-2-5, number 200 saved, the AASHTO requires us to have 0 to 35. Okay, 0 to 35. Again, our data is 34, so this is okay. Let's check the liquid limit requirement. The liquid limit requirements for A-2-5 is 41 plus. Okay, let's check. The liquid limit of our sample is 39%. AASHTO requires to have 41% and up. Therefore, this is not satisfied. And therefore, we eliminated the group classification of A-2-5. Okay. Next, we are going to investigate A-2-6, whether it is the group classification of our soil sample. A-2-6 requires the number 200C to have 0 to 35. Again, this is our number 200% passing, 34. This is okay. Going down, checking the liquid limit requirement, we have A-2-6, 0 to 40. Okay, so from the table, A-2-6 has a limit of 40% for LL. So this is okay. Going down further, checking our plasticity index, A-2-6 is 11 plus. 11 plus meaning from 11% and up, the plasticity index should be satisfied. Our data is 12% PI, therefore this is okay. So we are done. These three requirements are met, therefore our soil is A-2-6. Some textbooks gives a formula for the group index. You can find it in the book of Soil Mechanics by Brahadas, but in our classification chart, usually it gives the value for the group index. in A-to the 6, in the case of A-to the 6, our group index should be from 0 to 4. Okay? So if we are going to use the group index formula, we are going to give you the group index formula for A-to the 6. The group index formula is GI equals 0.01 F minus 15 multiplied by TI minus 10. Okay. Take note that this is the formula for the group index only for the subgroup of A-to the 6 and A-to the 7. We call this partial group index formula. Again, this is only for A-to the 6 and A-to the 7 subgroup. And we have to take note that group index is expressed to the nearest whole numbers. So if we are going to compute the group index of this soil sample based from our data, 0.01 multiplied by F is the percent passing number 200. In this case, we have 34 minus 15. So this is 34 minus 15. And then we have the plasticity index, which is 12 minus 10. We are going to compute our GI for this sample is 0.38. As a rule, the group index should be expressed in the nearest whole number. So what is our group index? This is 1 or 0. It should be 0. Okay, so finally, your answer should be, or the classification, soil classification should be written as the group A-to the 6, and then affix the group index enclosed by parentheses as 0 here. Okay, this soil classification is somewhat difficult in the first time, but as you go on practicing with different test data, you are going to be familiar with this soil classification system. Just remember that in the process of eliminating subgroups, you always start with from the left going to the right. If one requirement is not satisfied, that subgroup is eliminated, proceed to the next subgroup, as we have done in this test sample. Okay, I hope to see you next time with more examples on this soil classification system by AASHTO method. Again, this system is particularly used in highway subgrade materials. Thank you and see you next video.